the data that we ended with in section 4.5. So how we go about doing this, it is on that last video from from Tuesday from section 4.5. But let's go over it one more time. We need to get a graph page. Okay, so if you haven't done so, go ahead and put in a graph page. And then we need to change the graph type, because right now we're in a function, so we go to menu and graph type, and we do a scatter plot, and then we have to identify what the input and the output is. And on both Inspires, on the gray model, it's over here on the left side. On the black one, it's here. And which is our input, and so we choose our input, and then we go back and do the same thing for the output data. Okay, and when I press enter, we see that. Now a window, that's not a really good window. What we need to do is go from about -1 to maybe 5, and from maybe -1/2 up to 1. So I will change a window accordingly. Okay, so there's my scatter plot. Now the reason we need to do a scatter plot is because although our problem tells us what regression model to use, in the world, outside the math classroom. And again, I deal with so many people who look at me with that ugly look and that terrible comment of, yuck, I hate math. And the reason is because they don't know what math is. They don't know what algebra is. They don't know. All they've done is have X's and Y's, and that's why I try to work with you so much to get you away from talking about X and Y all the time, because we don't know what that represents. But when we talk about math out in the world, we gather data, and the first thing we do is just we take in. You're constantly taking in data as you live. And then we don't know what to do with that data unless we get a picture of it. And that's why the scatter plot's so important. Now that I see a picture, I can kind of see a trend going on, and that's where we go then in the world with mathematics. So the trend here, would you say that it's a constant increase? Doesn't look like it's a straight line. So there's some curve to it, and so the picture can help us with that. Now, it does tell us in our notes to use a quadratic. So we're going to go back to the spreadsheet and put your cursor in the, and Control 7 gets you to the top of the list. Put your cursor in cell C1. Go to Menu, Statistics, and Stat Calculations. I'll do that again. Menu, Statistics, and Stat Calculations. And under Stat Calculations, we'll pick up quadratic, because that's what it's telling us to do in our notes. Where do you find the input data? And so if we open up that menu, the input data is liters. Go down to the Y list, the output. Where do you find the output? Well, it's what we call concentration. Where do you want to save the regression equation? Now, I know all of you have probably done this with the 83, 84, so you know that what we're going for here. We need to save the equation. And so we're going to save it in F1, and if you just tab all the way down, then we get down to this first result column, and what it's asking is, where in the spreadsheet do you want to see your results? Now, we can start it in D, or if you want, you can just back that up and put a C, because we have nothing in column C. But you could put it in column Y if you wanted to. It's way out there if you wanted to. Okay, so there's our information. Now, we know that the regression equation is, the quadratic term, the linear term, and the constant term. And so now we have the coefficient for the quadratic, the coefficient for the linear term, and then our constant term. So we have now created that. Go back to your, go over to your graph again, and we want to look at that graph. So we have it set up for a scatter plot. We just do the same thing we did before. Menu, graph type, and what type of graph do you want to do? Well, you want to do a function. Okay, we have to go up and find that. Now, why not just put in, if you just record on your paper, let's see, it's going to be negative 0.008 x squared plus whatever that, linear. Well, it's not exact enough, and the Inspire's keeping all of those. So if we do that, it looks like it's a pretty good graph of that. Okay, so now let's go down here. It says use the regression feature and find the model. So let's record. And again, when you record, I don't expect you to record all those values. That's ridiculous to do. So we'll do C1 equals, and I have here in my notes, negative 0.008004 L squared. And make sure you make an L that looks like an L, not like a 1. If you go back, you'll have no idea if it's a 1 or whatever. Plus 0.08645 L plus 0.0252345. Okay, so we did part A, we did a graph of that, we got that. But it's telling us maybe it's not quadratic, maybe it's more of this rational. Now, my question would be your question, so how did they come up with this? What is in here that they thought, who did this? I don't know, is my answer. I don't know who decided that this rational function might work, but someone did. So we'll just take their word for it if you don't mind. And so let's graph C2. So we know how to do that. Press tab to get that back. And we need a fraction. And let's see, it's 5 plus 3L. We have to use X for the Inspire here. And 20 plus 4L, X for us here. And if you recall from Tuesday, they look pretty close. What's going to be the difference? If they both work, why bother? If they both work, why are we even bothering with that? Now, what I'm going to do while you're thinking about that, I'm going to try to find my Y2, and I want to change the attributes on that so I can see Y2. And I'm going to make sure that when I do that, it's pointing at graph 2. And I think what I'll do is just change it. Oops, missed it. Change it to a maybe a dotted line or something so I can see what that is. Nope, I probably didn't take it. Okay, didn't press enter on that. So again, my question is, why do we even want to bother with looking at a different line, a different model? Where might it start making a difference? Obviously not here, right? But where? Yeah, absolutely. That's the idea. Right here it's okay. But it's called extrapolation. Have you heard that word before? Interpolation and extrapolation. And that's what we do. This is why math is so important out there. We can observe data now, but how do we know that what we see now is going to be what we have in the future? Don't know, but we impose a model on it, and then if we say, okay, we assume that the pattern is going to continue in this fashion, here's what's going to happen in the future. That's what's so important about mathematics. I just get goosebumps when I talk about this stuff. It's just, I don't know, I know you guys think I'm crazy, but that's okay. I've been crazy for 30-some years teaching math. So, but it's so important that we get a vision of why we're here. Now, I hear you talking about taking other courses and, you know, your reasons for wanting one professor over another or whatever. I hope that your main reason for taking a class is because you want the knowledge, not just the credit. The knowledge that that's your opportunity. It's your privilege to be knowledgeable. Okay, well, enough of that. Let's go on. So back to our notes. We looked at that. We did a graph of it. Okay, now, exactly as Nash said, the difference is going to be what happens, and I'm going to have a question there. I think this one, I'm not sure why. Let me stop and think here just for a moment as to why that would be negative. Let's, again, I can't justify having that negative, so I'm going to just cross that out, because if we have leaders are going to, you can't have negative leaders. So let's consider the limits of these. Okay, now this is where all of this fits into this section. Let's let the number of leaders go to infinity. What happens when you take the limit of the quadratic to infinity? What do you think is going to happen here? Well, what do you know about limits? If we're going to infinity, what does this term go to if the input's going to infinity? The constant term is going to be what? I'm taking the input to infinity. Does it change? No, that piece doesn't change. Does this term change value? It gets larger and larger and larger. But which one is going to outrace all of them? Which term is going to change? I can't say increase, but it's going to change in value faster than any other term. Obviously, the quadratic term. Okay? So if the input is going to infinity and you've got a negative coefficient there, what is the limit of C1 as you take the number of leaders to infinity? You're thinking too hard. Infinity, positive or negative infinity? Well, I've got a negative coefficient. It would be negative. Okay, now how does that compare to the model of the quadratic term? Tell me everything you know about a quadratic that has a negative coefficient, leading coefficient. Draw it for me in the air. What's the graph of a quadratic function with a negative coefficient? There you go. Absolutely. Do you see what's going to happen with this as we go farther? This curve, in fact, let's just go ahead and do something here. I'm going to change that to be, we'll just change it to be 100. Whoops. Grab that. What happened to that curve? Dropped off, right? Is that the model that we would expect? Is that what we would expect as we add more and more leaders? Well, let's see, what's our problem? We're saying that we start with a 25% brine solution. We add leaders of 75%. what's the concentration? We would expect the concentration to increase. Yeah, not to